So we just finished this example on the board. I asked you guys how complicated it was, how difficult it was, and you're like, I think I can kind of do it. A few of you are still like, what's dy dt and dx dt? You probably have to come in and talk to me about that one. But maybe go watch old videos. We reviewed the steps real fast, and then we said, what's going to make this any harder? Words. But look at the left side. Look at the right side. Which one is going to make more sense in your brain? And the steps of take a formula, take a derivative, plug and chug, we're done. The right side. The right side gives you numbers. The right side gives you what the number stands for and where to plug it in. It doesn't give you the entire problem, but things like when you read the velocity of a car after traveling for an hour is 50 miles per hour, you say velocity of a car, that's the s prime, that's the derivative of s or x, dx dt. Is 50 miles per hour such that t equals 1. Or you read water is being pumped into a swimming pool at a rate of 10 cubic meters per hour. Water being pumped in, what dimension is that? Volume. So it's dv dt. And if the water is increasing in the pool, it's going to be a positive 10 cubic meters per hour. Hour goes with time, cubic meters goes with volume. Third one's a little bit rough. A gear is revolving. Turning? What's changing if something's turning? The length?
Angles.
The angle. That was a little rough. But the gear is revolving at a rate of 25 revolutions per minute. Well, if I'm talking about d theta dt, I don't want revolutions. I want radians. This was a little tricky. They had to take the revolution and say 1 full revolution is 2 pi radians. I think some of you maybe are kind of like, oh, pre-cal, I think we did that once. Don't stress, this isn't like a huge thing for the AP, but gear revolving, the theta is changing, so d theta dt is equal to, if it's revolving, the theta is increasing, positive 25 times 2 pi radian per minute. Radian goes with theta, minute goes with time. Last but not least, the population of bacteria is increasing at a rate of 2,000 per hour. 2,000 what? 2,000 bacteria, of course. So we let a variable stand for how many bacteria are there in the sample, in the population. We can say dx dt is equal to 2,000 bacteria per hour because it's growing. This is going to be hard until we can make it look like this. Okay? This is going to be hard until we make it look like this. Okay? So, what if we saw something like this? What if we saw something like this? Go ahead and read it. A spherical balloon
Is that pi or
is inflated so that its volume is increasing at the rate of 3 cubic feet per minute. How fast is the diameter of the balloon increasing?
So 4/3 pi or square.
When the radius is 1 foot.
So it's a 4/3 pi or cube.
I'm going to quickly give, there's only one stack per group and there are 4 different problems. One person take charge when I hand it, someone responsible, and find the balloon problem in it. Okay, someone from group 1, someone else take charge. Okay. Group 2, someone, yes. Group 3, someone. Okay, group 4, someone take charge. Take charge. Groups. No, keep them all in one stack, but find the balloon problem for your group. Group number, I think I'm totally out of order. Karen, take charge. Take charge. Find the balloon problem for your group. However, peek at the other problems. Does the format look kind of similar?
Yeah.
I think there's a system to how to solve these problems. What do you guys think if all the charts look kind of the same?
There's no room for creativity.
No. Maybe there's room for creatively connecting pieces. Now, hold on. Focus. I'm just going to quickly model how I need you guys to think through these problems. Okay? Number 1, in your homework, are you supposed to write big paragraphs for every single problem? I guess you could, but didn't I say in pre-cal, for word problems, just summarize the info? Look at that chart real quick. Let your entire group see it for the balloon problem. what do you think summarizes, filling in what pieces would summarize the problem? Balloon is great to start, with a little colon or a little period.
Volume is increasing.
Filling in which of the empty boxes do you think would summarize the problem? The given and find, and there's one other box.
Picture.
Pictures. The given and the find, the pictures. The other two, the other three, are your work you're supposed to fill in. Now, hold on. Take a second. Hold on. When you look at the given and find, he's going to model something real fast. When you look at the given and the find, right? Are you supposed to be writing sentences in for this? No. You're not supposed to be writing sentences in. You're supposed to read the problem, understand the problem. Everybody see a balloon being blown up? What picture would we probably put for a balloon being blown up?
A balloon.
The balloon. But we're going to be ideal, and we're going to say it's sphere. It's a sphere. We're not going to deal with like irregular shapes right now. We're going to say it's a sphere, okay? And it says spherical, so we're not even going to put a little like, even though we could, and that'd be fun at all. And we could even put a little like, oh, hey, it's cute. Anyway, so how do you label this shape if we're dealing with, eventually, volume?
Make it a sphere.
True. Okay. Sure, make it three-dimensional. Okay, let's have fun with that. Then what?
Then you start
Stop
filling
judging.
it up with something.
Isn't radius something important to label?
Yeah.
Okay, now hold on. So when I go over here to the given and the find, question. Hopefully a lot of you guys are seeing this 3 feet cube thing and saying, I think he's kind of important, right? But what would I label him? Don't be writing anything yet. I know, if you want to. Just pause, my people in charge, you're just looking at it.
dV over dt.
Why dBdt?
Because it's the volume.
It's the rate of change of the volume. Okay, look. Stop writing if you're writing on paper, you're just looking at it. Find. They're going to tell you.
dr, d2r.
No. Read it. How fast is find the rate of change of the dBdt. But don't just identify the find, but identify the when.
d2r.
Well, what puts together volume and diameter?
2 r's.
Well, you see why we need to start thinking about the next part now? Now we've summarized the info, right, cool kids?
Yeah.
But now we need to think about what relates. You see my chart and why I made it the way I did? What relates to the quantities? What quantities? Well, what do you got? Well, I got volume. I think radius is important, and then I have this random diameter dude.
Okay.
Someone tell me something that relates volume and radius and diameter dude.
Volume. V equals 4.
V equals, anybody remember from geometry?
4 divided by 3.
4/3 pi r squared.
Cube.
Volume.
Hey, 2 is
Volume.
I said square, did I make?
Okay. But is that enough to relate volume and radius and depth?
No.
What's another formula I might need?
Diameter equals 2r.
Maybe I could do like a solving and a plugging in thing about it?
Yeah.
Or maybe I could take a derivative of him and a derivative of him and then do some plugging in thing about it? So what am I saying is the next step probably? What's next in your table?
Take the derivative.
Related rates. But how do you get rates from original equations? Take ddt. And if you take ddt, try to put it all together to get one nice equation that has what you know and what you seek, and you can plug in stuff that you also know as far as the when. And then what's the very final thing say?
Quick check.
But what do I have in parentheses? Only round the final answer, don't round stuff in the meantime. When you're rounding, only round to 3 decimal places, and then carefully include units. Now here's the dealio. Do you think maybe with 4 problems, do you think possibly you might get a little stuck in this process somewhere?
Yeah.
So then if you think you might get stuck in this process, guess what I kind of have up here? Given find. Pictures. Ooh, related quantities. Ooh, related rates. Now, if you look at this just related rate card real quick, did I put the whole thing on there?
No.
Nope, but I put the final one that you're going to want to be using. It's a hint. There's missing some stuff, but there's a hint. The person who's in charge of your sheets, put them down on the paper right now. It better be blank, or at least it's blank from whenever I told you to stop writing. Put them down. Let them go. You're not allowed to move around with those. They're going to stay in your groups. And once your team, your group, has collected all the possible clues that it can, you guys are going to come back together and try to fill in the problems as best you can as well, as a group all together. Now, hold on, what clues? I'm going to randomly pass out clues, and theoretically, each one in your group is going to get a different clue for a different problem. So how are you going to figure out all the clues? You're going to have to get together with everyone else that has the same clues from the same problem. You're all going to, because you're not allowed to write on the problem. You're all going to have your spirals, get them out, turn to the back.
Start racing.
Whatever problem you end up with a clue with, and whatever grouping of people that all have the clues that match up to fill in the blanks of your problem.
I like to do it this way.
Focus. You're going to have to quickly write down all the clues for your particular problem: ladder, balloon, rocket, or baseball problem. You're going to have to write it down in your spiral. You're all little detectives. Your spiral is your clue keeping book, your handy-dandy notebook. You're going to have to write down the clues that you get, because in just a moment you're going to have to rush back to your group and you guys are going to have to put them all together to try to solve all four. You got it? Are you writing on this?
Can we do it without?
And to be honest, I honestly don't think some of them you'll be able to get.
Okay.
Okay, now I did help you a lot with the balloon problem, and the balloon problem is in here somewhere. That one I assume that people will actually make match pretty quickly. Now, once again, does this give the entire problem? No. Now, to help us have some semblance of order, all you're allowed to take with you is a pencil and your spiral to write down the clues you're collecting for your group to be able to use. I'm going to go ahead and put one person in charge of each problem. Ready? Kelly has the rocket problem. She's going to stand up and move to this side of the room, and basically anyone who thinks they have anything to do with the rocket problem, you're going to go find her, or she's going to find you. Baseball problem, that's Jeremy. Balloon problem, that's Josh. Ladder problem, that's Noah. Now, hold on. Hold on. Before I keep going any further, you guys have already read the balloon problem. Let me give you a second while I'm passing out stuff to read. Aw, struggle. That's okay, kind of read. The ladder problem. Don't move yet. Don't lose your little cards. Don't write on them. You guys get the pictures. You guys get the related quantities.
This is homework.
This over here. You guys get the related rates. You guys get the units, what all the answers should be. And, hold on. Carla, you're going to come up with Kelly and team up on the rocket problem. Madison, you're going to come up with Jeremy and team up on the baseball problem. Emily, you're going to come up and team with Josh on the balloon problem. Lucy, you're going to team up with Noah on the ladder problem. Tom, I have nothing. Hold on. Who has the one that says d theta dt somewhere on it? Who has a card that says d theta dt? Tom, you're going to go ahead and help Amy find where she needs to go. Okay. You guys have read the ladder one? Ladder, being on the wall and slipping down, right? I think that forms a triangle. Next one, baseball diamond. It's a square. A guy's running from second to third. I think it involves a triangle too. Last problem, camera mounted at a point, rocket shooting up, and the angle is changing. My 4 people, Kelly, up over here. Jeremy, up over here. Noah, up and in the back. Noah, up and in the back. Josh, up and in the back. Ready, set, find your team, go.
Josh.
Careful. You have to have the pictures, match the quantities, match whatever's going on. Go, up and go. You gotta split apart. You gotta split apart. You gotta go find who you're with.
I think.
Start shouting it out. You gotta figure out who's with you. Make sure the variables match, otherwise you're in trouble.
The rocky and the ladder one.
Already started solving.
You know, well, I haven't.
Oh, it's still full. I got
Just start saying for a minute.
Gabby, is that the balloon?
No, this is the ladder.
Who's the balloon?
You start calling out X's and Y's. Who has a picture? The picture's gonna help. Hey, look. Rocket, there's a picture, but I see Y and I see theta. I see Y and I see theta.
I feel like this one. I'm not too sure. What did you do?
Wait.
I'll just keep
Alright, while you guys are writing, I'm gonna start solving.
Yes.
You're done.
And at three. Oh wow. No, I don't. We can find this distance, and we can find that. We can find this. Oh yeah. Sorry, I'm really focused. White balloon. I can do it. I can we derive this, and then we plug the R and the B. Because it's asking for the I could find this at home. It's like, yes. No.
Because I'm filling in the clues and I'm filling in the in-between spaces. I'm saving them on the notes online. I want the one person in charge who took the papers from me to go ahead and collect them. I'm going to save the clues online. We might go ahead and make sure you are all able to answer that's all the way to the answer tomorrow. But hopefully at least seeing what these clues look like will help you in starting, maybe finishing, but at least starting 2-7 homework tonight. Get in there. Get working on 2-7 homework. Study your forevers. We'll finish this activity tomorrow. Put in your spiral, my responsible ones that took it from me. Corrections! Real quick. Pass them back. Pass them over. Leave them on the desk. Somebody will just leave them on the desk right next to her. 2.7 is technically due tomorrow, but since everything's been delayed, it'll probably be due on Thursday. I mean, it's Wednesday, but some people won't be here Wednesday.
So the justice.
Technically, 2/7 is due on Wednesday.
Yes.
Try and have it done by then.